In this video, we will dive into one of the most commonly used React hooks, UseState. This hook allows us to add state to functional components. With TypeScript, we can strongly type our state values, making our application safer and easier to maintain. Let's first understand what is UseState. React's UseState hook lets you store values that persist between renders. State changes trigger re-renders, updating the UI automatically. This is the syntax. Const state comma set state is equal to use state type initial value. Here state is the current value, set state is the function to update the value. Type is optional TypeScript generic to define the state type. To understand this, we will see one example of basic counter, that is number state. First, we import React and use state hook. Use state will hold our counter value and let us update it. We define a functional component named counter and export it as a default from this file. And then we will declare the state for the counter. Count is a number starting at 0 and setCount is the updater function. The number generic enforces that the state is always numeric. Then we define an increment function. It uses the functional form of setCount. Prev is the previous state, so updates are correct even if React batches them. And then we will define a decrement function. Same pattern, take the previous value and subtract 1, ensuring safe, predictable updates. And now we start returning the JSX that describes what this component renders. A wrapper element to group the counter display and buttons. We will display the current value of the count when count changes. React re-renders and this text updates. A button that calls increment on click, increasing the counter by 1. This is a button that calls decrement on click, decreasing the counter by 1. Close the wrapper, close the JSX written by the component, close the component function, the counter is ready to use. Using the functional updater previous arrow mark prev plus or minus 1 avoids stale state bugs during rapid clicks or batched updates. Typing use state number in the tag 0 prevents setting non-numeric values and gives the intel sense everywhere count is used. Let us see one more example for string state, that is input field. First we import React and use state hook. We will use state to track what the user types into the input. Then we define a functional component called nameForm and export it as a default export. And we create a state variable named name and its updater function setName. We type it as a string using string tag and initialize it with an empty string. This is the change handler for the input field. It receives a change event from an HTML input. Every time the user types setName updates the name state with the current value of the input box. And here we start returning the JSX that describes the UI, a wrapper div element to hold our input and greeting. This is the text input field. Type is equal to text means it's a plain text box. The value is controlled by our name state, making it controlled component. Whenever the user types on changes calls handle change which updates this state. The placeholder shows the hint text enter your name when the field is empty. This paragraph displays a greeting. If name has a value, it says hello followed by the username. If name is empty, the logical OR operator shows the word stranger instead. We close the div, close the return statement and then close the component function that completes our nameForm component. And this is how our output looks like. This example demonstrates how UseState works with the text inputs. The input is fully controlled by React state, making the UI always stay in sync with the data. Now we will see one more example for Boolean state, that is toggling UI. First of all, we will import React and use state hook. We will use UseState to keep track of whether the message should be visible or hidden. Then we define a functional component called toggle message and export it as a default export. Here we create a state variable called visible typed as Boolean. It starts as false, meaning the message is hidden by default. SetVisible is the function that will update this state. And then define a function called toggle. It flips the state. If it was true, it becomes false. If it was false, it becomes true. We use the functional form prev arrow mark not prev to safely update based on the previous value. We now return the JSX that will render our UI, a wrapper div to contain our button and messages. This button calls the toggle whenever it's clicked. Inside the button, we use a conditional expression. If visible is true, the button says hide message. If visible is false, the button text says show message. This line conditionally renders the paragraph. This double ampersand operator means only render this paragraph element if visible is true. If visible is false, nothing is shown here. We close the div, close the return statement, and finally close the component function. That completes our toggle message component. This is how output looks like. This example shows how useState works with the booleans. It's very common pattern in React for toggling visibility of models, drop-downs, menus, and notifications. Now we will see one more example for complex state, also called as objects. First we import React and useState hook. useState will allow us to store and update users' profile information. Then we will define a type script called user. It ensures that our user object always has a name as string and an age as a number. Then we will declare a functional component called user profile and export it as a default. Here we create a state named user typed with the user type. We initialize it with an empty string for the name and 0 for the age. SetUser is the function we will use to update this object. This function updates the name property for our user object. We spread the previous state with priv to keep the other fields intact and then overwrite name with the new input value. This function updates the age property. We again spread the previous state but this time set the age. Notice that we wrap the input's value in number to convert the string input into a number. Here we start returning the JSX that defines our UI. This is the input for the name. It's controlled component. Its value comes from the user.name. Whenever the user types update name updates the state. And this is the input for age. Its value is bound to the user.age. When the user types update age updates the age in the state. This is the paragraph conditionally displays a message. If the user has entered a name, it shows the name and age together. If the name is still empty, it falls back to the text, no user yet. Close the div, close the return statement, and finally close the component function. That completes our user profile component. This example shows how we can use useState with objects in TypeScript. Notice how we update individual properties with the spread operator, making sure we don't overwrite the rest of the object. Some of the best practices are always type your state in TypeScript for better safety. Use state prev arrow mark when updating based on the previous value. Keep state minimal and avoid nesting deeply. For complex forms, consider splitting state into multiple useState calls or using useReducer. Let's summarize. UseState adds state to functional components. You can store numbers, strings, booleans, objects, or arrays. TypeScript generics help ensure correctness. State changes trigger re-renders, keeping UI in sync with data.